Hello, good morning, class. This is today me, Dante Edmonds, and
Hillary Torrey teach.
we're going to be giving a project PowerPoint presentation on spherical geometry and its applications. Our class subject is going to be Math 312, History and Mathematics. Alrighty, first, you may ask, what are we going to talk about? Well, we're going to talk about spherical geometry and some of its applications. We're going to give you the history of where it came from and why. Because you may say, oh, spherical geometry, we don't really need that. But I'm going to tell you why we do need that. And then I'm going to tell you about possible future developments and give examples of spherical geometry and some interesting facts about it and real world examples. Alrighty, so let's get to the basics. What is spherical geometry? Spherical geometry, in a sense, is just the study of figures on the surface of a sphere. It has lines that are represented by great circles, and angles and distance are measured along the surface of the plane rather than a flat plane. It's important for like navigation, astronomy, and mapping. It helps work with curved surfaces. So in a sense, this is working with like when our phones tell us where to go, that's spherical geometry. Because in this PowerPoint in the future we're gonna learn that it's easier it's not easier to get a map and go straight to that point. And I'm gonna cover that during this PowerPoint presentation. Alrighty. So what are some of the applications you ask? Astronomy, navigation, geography, engineering, computer graphics, and gaming. I just want to point out there's several more. This is just some of the basics I listed out, and you know some of the main ones, but there is plenty of more that you could do. Alrighty. Um, Now I'm going to get into the history of spherical geometry. So dealing with history, the origins of spherical geometry, they can be traced all the way back to ancient Greek. They needed to understand a sphere to track the movements of stars and planets. It wasn't really until the works of math magicians such as Euclid that more formal foundation began to take shape. So could you imagine, like, just like us going straight to a point and just walking there, and the next thing you know, you have all these like things in the way, but and you can't really measure the distance. So you may ask, why does this guy keep talking about spherical geometry? Well, now I'm going to tell you why. It's important because it allows us to better measure curved surfaces. So like if you grab a ball, it's hard to just measure. So it allows us to measure. And then it's important because, like I said, it helps us deal with navigation. It helps us go the most direct route. You may think that just going straight there is the most direct route, but it's not. And then, like I said, we'd have to measure everything flat, and it would not be that accurate. Um, so now we're gonna go over spherical geometry, trigonometry, formulas and equations. So you have three different types, and I just want to point out on this as well. You have more, but I just list some of the more basic ones. So you have spherical law of cosines, spherical law of sines, and excess angle formula. So explaining the excess angle formula. It's the sum of angles of a spherical triangle that exceeds 180 degrees. What you're going to learn, you're like, oh, a triangle's only 180 degrees. What are you talking about? Well, later in this PowerPoint, I'm going to teach you that dealing with spherical geometry, you're going to have triangles that exceed 180 degrees. But this is by the area of the triangle divided by the radius of the sphere squared. So mathematically, it's a plus b plus c squared equals 180 degrees plus area to radius to the second, where a, b, and c are the angles of the triangle and r is the radius of the sphere. So, like I said, this is just a few. Uh, there's going to be plenty more. Alrighty, now we're going to talk about properties spherical surfaces. So a spherical surface is a set of all points that space in a space that are a fixed distance, the radius from a given point. All right, like I said, you have great circles, and then you have small circles. So great circles divide. Think about, you have a spear. That's gonna cut that spear into half equally and give you two equal hemispheres. Now, a small circle, it's going to be here, here, here. It could divide the sphere into two unequal hemispheres. If you put a small circle here, here, you're going to have an unequal other side of the hemisphere. Alrighty, some interesting facts that I found interesting when I was doing research on this, because I didn't know anything about spherical geometry. Um, So, like I said, two parallel lines on great circles intersect twice. That's crazy. Then I learned that the sum of three angles of a triangle on the sphere's surface exceed 180 degrees due to positive curvature. So that. Like I said, that explains. I never knew that. You can have a triangle more than 180 degrees. Did you know that?
No.
Yeah, man, we learned a lot doing this research project. And then, like I said, the shortest route to get from one point to another is not a straight line on a map, but it's a line that follows the minor arcs of a great circle. So, like I said, you may think that you can just directly get there, but it's not. And then, like geometry and geographically, the words, the worlds of spherical geometry and planar geometry are commonly taught in geometry courses. They're closely related and yet extremely different. Alrighty, now I'm going to go over some coordinate systems used. Alright, so you may, like, when do I use this? So we use this geographic coordinated systems. Alright, we use this locating points on Earth's surface, latitude, and longitude. We use this with our GPS navigation systems. And then we have a celestial coordinated system. It includes coordinates like right axis and declination to locate objects on spheres. So examples of that's going to be stars, planets, and galaxies. So like I said, we wouldn't even know how to get to space if we didn't have this. And I know plenty of people every day like, oh, why am I taking this class? Why am I taking geometry? I'm never going to use it. But I promise you, we use it more than we think every day. All right, now I'm going to pass it on to him, and he's going to teach you the rest.
Okay, now I will introduce you to practical application in the field of physics. Okay, first, physics is not physics without math. Because when you're working with magnetic fields or radically okay, it's also used in quantum mechanics when describing how heavenly bodies move, interact, and occupy space. There's some more to it, but that's the most interesting parts about the relationship between physics and spherical geometry. Okay. Of course, spherical geometry comes with limitations and challenges. For example, it's require accuracy. It's difficult to construct uh, evidence, and also working in high demolition spaces adds more complexity and difficulties.
Yeah, I could see a limit challenge working with that. Like you said, it requires accuracy. So math, anything in math requires accuracy because if you mess up one number at the very beginning of your problem, you're gonna mess up your whole equation's messed up. So I can
Yeah,
see how that's very true. That's definitely a challenge and limitation working with any type of math.
yeah. Okay. Of course, it comes with real world examples like pilots use it when uh, use it for coordinates when you're going from Raleigh maybe to Texas. Uh, pilot uses spherical geometry to look for the routes and distance and speed. I think you're wondering why how the spherical geometry and its importance emerge. Uh, Astronomers utilize it to determine the position of the stars, planets, and other heavenly bodies. It offers the mathematical foundation for figuring out locations, angles, and the length of the space surface of the Earth. Also, when you're driving your car, of course, you use GPS, so that's one of the essentials of the spherical uh, geometry. Okay, the spherical geometry also is used in designing a building. Architectures use it when they're constructing a road. Uh, they use it in urban planning. They use it. Yeah, those are one of the examples which spherical geometry is applied in architecture and designs. Also, it's used in computer graphics and gaming. When you're playing a video game, you're using a spherical geometry because uh, it gives you a reality of certain things like you're flying a fighter jet, but in reality, it's just a simulation. That's because of the spherical geometry applied in computers for graphics and gaming. Also, in a natural phenomenon, over time, certain geologist formation include many transform into spherical forms. Like when you look up at the moon seems like it's a cycle, but it's naturally it's a sphere. Even the earth is a sphere. That's why when you're doing uh, that's why when you're calculating any form of math in calculating the earth surface, you use the formula of a sphere. Uh, I think you'll be wondering about the spherical geometry in various disciplines. One of these is I've told you earlier is using to compute distance, which are crucial for daily duties like land surveying, satellite positioning, and the model of the Earth. And uh, even in X-ray, they use a spherical geometry when they're analyzing the X-ray. What do you learn about the this spherical geometry when you're discussing it?
Yeah,
What are
man.
some conclusions about
Yeah.
the spherical geometry?
So basically, man, what I want people to take away from this is understand that this is something essential that we use daily, and it teaches you how to measure a sphere, and it also taught me that there's more than 180 degrees on a circle when you're speaking in sense of like spheres and stuff like that. And like I said, it gives me formulas how to calculate this for like excess angles and stuff like that. So I feel like I learned a lot because I never knew this was a thing. I just figured I never knew. Actually, I kind of never thought about how do we measure
Yeah,
or measure. spirit spears and stuff like that. I just figured I guess it's nothing that really crossed my mind. In a sense, like I said, we can measure a paper, but and that's accurate, but we can't measure a spear and just go around it and it be accurate. We have to use the minor arcs and
Yeah,
in order to be accurate for that. And also I learned that there's great circles and small circles on spears.
yeah,
So, like I said, I learned a lot in this. And then also I learned, like he was talking about, I learned that and they use it in gaming.
yeah.
I
I
always,
never thought of
yeah,
it
man.
too. It
I
was
always
just
wondered how games are really taught, but I
yeah,
guess y'all understand now. Hey, we use this, we actually use spherical geometry, and I hope y'all take this, and I hope y'all learned a lot. But I hope y'all do more research on this and this topic and learn more and go deeper into this because there's more deeper into this. Like I said, I learned gaming, learned how to measure it, learned that we use it in navigation. We all quick to do this stuff, like just click buttons, but we never see the math and science behind it. So I feel like that is something that we are learning and that I learned from doing this and that I feel like y'all should have learned from us doing this PowerPoint.
yeah,
What'd you learn, man?
yeah. It was very interesting knowing that spherical geometry is applied in computers. I thought computing is about only coding. I never thought like spherical geometry is included in it, like creating a visual wall and visual environment. You need a spherical geometry, which was an interesting thing to learn. Yeah,
All right, and then also, what else? Oh, yeah. Also, I want to touch back on the applications. I hope y'all do y'all's research and learn about more applications. Because, like I said, I just list a couple that's vital to our day-to-day basis, but there's plenty of more that you could do research on. So I hope we taught you a lot during this class or block of instructions, and I hope you learned a lot. Feel free to reach out to me if you have any questions. Thank you.
thank you.